We now know how to read out the correct status code and use that information to act on it. Sometimes more is needed. APIs might return information to show to the user in the response body, or the response body might contain a list of validation errors you want to show in the consuming application. For example, in case of a 422, the response body often contains the written out model state validation error dictionary, which can then be used by client applications. Let's learn how we can do that. In this demo, we'll learn how to read out the response body in case of an error. Let's mimic an invalid request that results in a 422 status code when creating a movie. Let me paste in the code we're starting from. There's nothing new to see here. We create a new movie, we post it, and we read out the response using streams. The movie object we're creating is valid. We've used the same property values before. Let's see how we can make this invalid. For that, let's open the movie for creation DTO at level of our API. We see that quite a few data annotations have been applied to its properties. Some fields are required, some have a maximum length, some have a minimum length, and so on. Let's go back to our service. The movie description had a minimum length of 10, so let's change this to a description that's too short. That should trigger a validation error. If we scroll down a bit, we see that we still call response.ensure success status code. We don't want to do that anymore. We're going to use the approach from the previous demo to inspect the status code. So we check out if the response is successful. And if it isn't, we want to handle the 422 status code. 422 is an unprocessable entity. This is the status code you typically use when building an API and you want to return validation errors. So what we want to do here is read out the response body which contains these validation errors. The thing to keep in mind here, and that's what I want to point out, is that we can't just access the content. Remember that we're sending this request with the HTTP completion mode set to response headers read. So the content will still come streaming in at the moment we try to read it out. If we don't use a stream for that, this will fail. To fix this, we call read_as_stream_async on the content. And on that error stream, we call read and deserialize from JSON. That's one of the methods from Marvin.stream extensions. Once we have the validation errors, we write them out to the console window. Important here is that we stop executing this method now, so we need a return statement. In regards to other errors, for our demo, we'll simply throw an exception if those happen. For that, we call response.ensure success status code. That should be it. Now let's make sure we call this method when we run the application. And let's give this a try. And there's the validation error. So by using a stream, we can read out the validation error from the response body. Let's continue with learning how to deal with APIs that aren't really built according to best practices. In a perfect world, APIs are built according to best practices and correctly use status codes. But this isn't the perfect world. In fact, I'd argue that most APIs are not built with today's best practices in mind. That also means that not all APIs correctly return status codes or are specific enough about them. You might even encounter APIs that always return a 200 OK status code and rely on the consumer to inspect the response body for a field that might indicate whether or not the request was actually successful. This is what the Facebook API does, or used to do. It's been quite a while since I've used it. In any case, your mileage may vary, but with the two techniques we just looked into, issues like this can be solved. For example, if the API only returns 200 OK status codes, don't rely on that, but parse the response body and inspect that using the same principles we just used for reading out a response body with validation errors. We're not fully finished yet with dealing with errors, but we are with this module. Let's have a look at the module summary. We learned that a status code can tell us something about whether the request was successful or not and whose fault it was, the client or the server's fault. By using Ensure Success status code, we're throwing exceptions even if the client made a mistake or can handle the error. In this module, we learned a better approach. We can inspect the status code of a response and act on it. Next to that, we might need to read out a response body. Important to remember is that we should use streams for that, as thanks to the response header's red HTTP completion mode, the response body can still be coming in when we try to deserialize it. By combining status code inspection and reading out a response body, we can nicely integrate with an API that doesn't play by the rules. Sometimes, dealing with issues goes beyond just showing a message or logging something. Automatically retrying a request when it fails is a good example of that. So is correctly dealing with timeouts. Custom handlers can help with that, and we'll learn about those in the next module. In the beginning of the course, we learn about custom message handlers. In this module, we'll learn how powerful they can be. I'm Kevin, and I'll guide you through it. We'll start by looking back at how we can chain together custom handlers to form the delegating handler pattern. After that, we'll use that knowledge to implement a retry policy and a way to handle timeouts better. We'll also cover some additional use cases these handlers can be used for. Let's dive in. Let's look back at the diagram from the beginning of the course. We learned that a request flows through a set of message handlers that can be chained together. In other words, they result in a pipeline. The request is received by the first handler in the pipeline, potentially does some processing and passes on the request to the next handler in the pipeline. Eventually, a response is created and travels back up the pipeline. This pattern is called the delegating handler. And that's what this module is about. We can create our own handlers and inject them in that pipeline. Creating such a delegating handler can solve a lot of common use cases like retrying or better handling of timeouts. We'll implement both in this module.